Hi there folks, in today's demonstration I'm going to show you how you can export data from Power BI to an Excel file. So what makes my video different from everyone else's is this is actually an Excel file. It's not a CSV and I'm not using an apply to each to write the data. So where you might write tens of thousands of records or rows from Power BI to an Excel file using apply to each and it takes 2 hours, my flow will complete in about 15 seconds. I'm going to show you two different methods using either the Graph API or Office scripts, and I'm going to pitch myself against the traditional method, the apply to each. Can I show you all of this before my apply to each flow completes? Will the graph or will Office scripts be faster? So if you haven't already, please make sure you like and subscribe, and without further ado, let's see who wins the race to write data to Excel. So for today's demonstration, I've set myself a challenge. I have a flow pre-built that is going to add 20,000 rows from a DAX query into an Excel file. So that Excel file already has a table, and you're probably thinking, this is not what I want. I've seen loads of videos that do this. Well, that's the point. I'm going to run this flow, and my aim is to complete this demonstration before this flow completes, and then I'll show you the flows that run extremely efficiently. You'll be able to write 20,000 rows of data in under 20 seconds via two methods, either Graph or Office scripts. So just as a quick explanation, I have this run a query against a dataset. We can see that it gets the top 20,000 rows from my dataset that I have parse JSON, which enables me to get all the values dynamically, and then I have add row into a table, which is in an apply to each loop. So this is going to run 20,000 times. If we go and put this into test mode, the time is ticking. I now need to go and show you these other flows and do my demo. If I jump across onto Power BI, the service, you can see I have a sample report here with the data that I'm actually crunching, and I've got a button which can run a flow. So this is one of the methods of running a flow from Power BI data. I can click on this button here, we can see it's triggering. The limit here is 1,000 records at the moment. So this is going to run a very basic flow. It's going to save 1,000 records or 1,000 rows from this data source into an Excel file. And if I was to jump across onto my SharePoint site and do a quick refresh, we can see that we have a file that's just been created a few seconds ago. And if I pop that open and then jump to the bottom, I have 1,000 rows, or 1,001 because there's a header. So that was how quick the flow run in order to generate an Excel file and populate it. So in this flow, I have the trigger for when the button is clicked, nothing else there. I have a select, which is repurposing the data from the Power BI values array and simply putting in the square brackets, the opening square bracket and the closing square bracket, and then 4 of the columns that come through dynamically into this array. So in order to get into this view, you need to make sure that you switch from the map to the text mode. So this repurposes the data, turns it into nested arrays, and the bonus with the nested arrays is that it's set up to either send to the Graph API or to the Office scripts. But before I do that, I have a send an HTTP request to SharePoint, and what this is doing is it's creating a blank Excel file, 100% blank, brand new Excel file based on this API call, and it's with this Excel file that I then run my Office script, and that Office script will take an ID from that HTTP request, which is the ID of the file, and then it will pass across this worksheet data that comes from our select. So this is all that we have in our first solution in order to populate a file, the limit of 1,000 records, but it runs incredibly quickly. And if I go back into the history, we can see that at 7:31 tonight, it ran in 3 seconds. That's how long it took to populate that file. We can have a look at the select. We can see all of those rows of data that have been repurposed from the array that came into our flow from Power BI, the send an HTTP request, which creates that blank Excel file, and then the run script, which calls our Office script to populate the data into our file. Now I'll have a quick look just to see how that flow is doing. We can see it's still running, it's still populating all those rows. Hopefully I've got enough time to complete my demonstration. If I pop across now onto Excel, this is a look at the Office script. So you can see on the right hand side, I have a script, it's JavaScript, and it takes a few different parameters, including an option, a Boolean option for does it include a header or not, because I can pass across a header with my array and that will add it to my table. Do I want to format this data as a table so that it's therefore accessible using the native actions to list rows, etc. I have a sheet name, which is the default sheet name, will always be sheet 1 unless you've got a workbook with different sheet names that you want to populate. And then you'll see I've got the worksheet data array, which is the nested array that I created with the select. So all that's doing is just doing a little bit of calculation to see where it should start based on the size of the data. And then it's chucking all that data into the sheet in one big go, which is why it took 3 seconds. And at the very end, you can see that I'm formatting the data as a table if the Boolean value of format as table has been set to true. And you'll see all those settings in the run script action in Power Automate. Now I'm going to jump across onto the new designer. The reason I'm doing that is I'm now running this flow from the manual trigger. And I have the same action as before. I'm running a query against a data set, and I have a DAX query that's getting 20,000 rows from this data set. And then I have parse JSON. So with the parse JSON, I've simply run this initial action. I've got a copy of the data as an output, and then I have used a sample payload, which has come from the history of the flow, pasted it in here to populate this schema and allowed me to call the data within this array dynamically. Then you'll see I've got a compose action, and that compose action is a nested array, a single nested array. It's got some column names in it. So column 1, 2, 3, 4, 5, 6. Now I could have these column names as anything I please. It's entirely optional, but it's for my Office script. Do I want to include the column names or do I not? Then I have a select, and that select is exactly the same as we saw on that first flow. In this occasion, I have the body from the parse JSON, but again, I've put the select into text mode using this little switch here, and then I've supplied the dynamic values into this array. So square brackets, dynamic values, and then commas between all those values, and that gives me a nested array. Then you'll see I've got 2 branches. I've got a left-hand side and a right-hand side because I'm actually creating 2 versions of the file. I've got 2 methods, of course. I said there's 2 fast ways of doing this. The first of which is involving the Graph API, and I've got a video of that already. And then the second of which is using Office scripts. Again, I've got similar videos. I've just made this slightly more improved and slightly more efficient, if you can believe that. So on the left-hand side, we have the send an HTTP request. Same as before, I'm creating a brand new file. It's called Excel Graph API.xlsx. On the right-hand side, I have that same action, and I'm creating a file called Excel Office Scripts.xlsx. If we now work our way down the left-hand side, you see I've got some letters A through to Z. So this is needed as part of the Graph API. And the reason I've got this is I want to dynamically calculate the cell range. If you think about the cells on a sheet, in fact, if I jump onto Excel now, we can see that if I select the following cells, I've got a range of A1 down to E6, and that would be 5 columns and 6 rows. So the Graph API needs to know the range for the data that you're providing, and therefore we need to calculate it dynamically. So that's why I have a compose with the letters A through to Z. Then in my next compose, I have a simple expression. I say it's simple, but if we start from the middle, I'm getting the length. If we start from the middle, you'll see that I'm getting the length of the first object in our select. Now the first object in our select is going to be one of those nested arrays, which is basically one row of our data set. And that one row is going to have however many columns there are. So if there are 6 columns, the length of the first body in our select is going to be the number of columns. And I need to then subtract a 1 from that. And so if there are 6 columns, we're now down to the number 5. And you'll see that whole expression is in square brackets. That's because we are now going to be selecting a letter from an array based on that number. And arrays can be selected using what's called an integer index. Again, I've got videos on this showing you how to build out expressions. But if we want to get the 5th letter from our string, we would get number 4, hence we subtract 1. The next part of the expression is based on the outputs of our letters. So we've got our outputs from our compose that has our letters A to Z. And if we use the expression chunk, we can actually turn that string into an array. So we're chunking into sizes of 1. So that'll give us an array of A through to Z. And then we choose the appropriate letter based on the length, which is the number of columns in our select minus 1. Next up, we have the dynamic range based on the starting cell of A1. We have the output from our compose letter, which is going to be the letter F because I have 6 columns, and then we have the overall length of our select. So if I click on that, you'll see I'm using the expression length of body select, which is how many records I've retrieved from that DAX query. So this is allowing me to be totally dynamic for our Graph API call. Into our first invoke an HTTP request, and it's worth noting at this point that this is a premium action. The Graph API is premium, however, the Office script is not. It's using standard actions, albeit you need to ensure that your IT have turned on the Office script's functionality. So you'll see I have a call here which is getting an ID for my particular site. So we have the name of my site, which is demobird365.sharepoint.com. I then have the name of my site, which is January 2024, and then I have a question mark and a $select equals ID, which allows me to get the ID of my site from the Graph API. And this is important because I need it as part of the request to populate the document. I then have another compose action, and that is getting the ID of the file that we've created. Similar to the first flow that I showed you, it's based on the body from the send an HTTP request, and there you're getting the D and unique ID. So you'll see in that expression it's on the screen, question mark, square brackets, and then single quotes, D/unique ID. So that gets me the ID of the file into compose action, and then I have the site ID, which actually comes across as a comma separated string. There are 3 values. I need to get the second, so I'm using the expression split based on the output of our HTTP request for the site ID, specifically the body ID, and I'm splitting that with a comma to get the second value. We've spoken about integer indexes. Because they start from 0, the second value is the number 1, hence why I have the number 1 in brackets. So that's allowed us to get both the file ID, the site ID. So finally, we jump into this action here. Again, another invoke an HTTP request, and this allows us again to call the Graph API. We pass in the site ID, we pass in the file ID, and then we specify the sheet name, which is sheet 1, followed by the range, which is the sheet name, exclamation mark, and then that dynamic range that we've created. So A1 through to the letter and the number of rows. As part of the body, you pass an object. You can see I have a key called values, and that values is a nested array. So the output from the select that I initially created with all that data from our DAX query is being passed in as the values. And that's it. That's all that's required in order to generate a file and populate it using the Graph API. And it's actually a quicker method than the Office scripts, but like I say, it is premium. If we jump back onto that flow, we can still see it is populating that Excel file. So it's still not completed those 20,000 rows. So let's see if we can get on to having a look at how the Office script feature works. So if we now take a look at the right-hand side, we've already covered this HTTP request that creates a file. I then have a compose ID, which, like the left-hand side, is simply getting the ID of the file name, and it's the send an HTTP request, and then a question mark with D/unique ID in single quotes. Far less actions required here. We're straight into a run script. We can see some of the properties that I showed you in the Office script when we were in Excel. So the script is called add data to Excel from array. There are script parameters. So do I want to include a header? Yes, I have. Do I want to format the data as a table? Yes, I do. And what is the name of the sheet? So sheet 1. You'll see that in the worksheet data parameter, I actually have a union. And what that's doing is it's bringing together the compose that we saw at the beginning that has the column names with the body select. So the reason I have that is because I have include header set to yes. So I'm combining the data that's come from the DAX query that I've repurposed with the select with the compose that has my column names. If you just want a quick reminder, if I jump up to the compose here, we can see I have my nested array. Make sure you've got 2 opening square brackets and 2 closing square brackets, but I have my column names 1 through to 6. Of course, this isn't dynamic, it's fixed, but it might be something you want to have in your data when you populate your file. The select is just that data dynamically from the parse JSON, which of course is from our DAX query. So back into our run script, if we have a look at the file is based on the output from this compose file ID above, and we've already covered the content of this worksheet data. If you didn't want the headers, then of course you could remove this and insert the output from the select above, and of course you would then turn off includes header because the select does not include a header row or a header object. By default, the DAX query doesn't include it. Scrolling our way down, there's nothing else to that flow. That Office script that I've created does all the work. It accepts the nested array, it adds the data to the file. If I've got any of those parameters set, it will create a table, and if I've included a header, it will know based on the yes or the no. To finish things off, I have get file content using path, and all I'm doing is grabbing the file or one of the files that have been created, the Excel Office script one, and then sending it to myself in an email. And you can see I've got an object here inside an array, 4 attachments that includes a file name and the file content. Jumping back to this original flow, it's still running, and if we go and jump onto SharePoint, we can go and have a look at this file with a table and maybe check the progress so far. So Control-Shift-End, we can see it's round about the 800 mark. Those rows are still being added. So I've actually got plenty of time still to complete this demonstration, but I can tell you that I'm almost complete. So why don't we give this flow a wee whirl? We know it's going to take 20,000 records from this DAX query, which comes from my Power BI dataset. If I put my flow into test mode, we can watch this flow unfold in front of us, have a look at some of the history as things go. We can see my column names there in the nested array. If we go into the select, there's quite a large chunk of data in this one, and I've already heard the ping actually to suggest that the email has been received. If we have a look at the output, we can see the nested array of data. As we move our way down, we've created 2 files for these send an HTTP request. We can see my compose, it contains the A to Z. If I look at the column letters, it's chosen the letter F based on the length, which is based of course on the select. We have the dynamic sheet range, which is A1 to F 20,000, because we know we've got 6 columns, therefore we've got the letter F, and we've got 20,000 rows in our select. We have our invoke an HTTP request, which is in order to get the ID of our site, and we can see that there, it's highlighted, and you can also see that it's comma separated, so we have a comma there and we have another comma there, which is why I get the second value with the number 1, the GUID that I've just highlighted. That allows us to get both the file ID and also the site ID that we see there. Then finally we have that invoke an HTTP request, which basically fires across all that data that's been generated in the select above into our Excel file. On the right hand side, very much the same, send an HTTP request to create a file, a compose file ID, which is just to get the ID of the file above, and then we have that run script action that takes all of that data from our select, hands it over to the script and lets it do its thing. So you can see the run script took 7 seconds, the invoke an HTTP request took 5 seconds, not really much between the two of them, and then we have the get file content and the send an email. So if I jump across into my email, I have one called Power BI Export, and there is a file there. We can have a look at the time, it's 7:49, so it's only about 15 minutes ago that I actually started recording this video. I can pop open that file and you can see that the data is in a table, But also if I jump to the very bottom of this file, we have 20,000 rows, or 20,001, because of course there is a header at the very top. So if I jump right back up to the top, you can see I've got column 1 to column 6, which are those values that came from the initial compose. So if I close that out, so if I jump across onto SharePoint, we can see those two files, the Graph API and the Office Scripts file. Of course, if I pop open the Office Scripts, it's exactly the same as the one that was emailed to us. If I just jump down to the bottom, there we go, we've got the full 20,000. And if I pop open the Graph API file, you'll see that again, I have all that data. There's no header on this one. It's not formatted as a table, albeit the Graph API can do that. And if I jump to the very bottom, we can see that we have 20,000 rows of data, all created within the space of about 20 seconds. Now, if I jump back across onto that Excel that's adding rows one by one using that loop, let's see how far it's got to. It's currently up at 1068, so still plenty of time, but that is the end of my demonstration. I've shown you how you can output those records into a brand new Excel file using two methods. One is premium, one is using Office Scripts, which needs to be enabled at tenant level. But assuming you have that all in place, you can see how you can very quickly output data into Excel from one of either two methods that I've demonstrated today.